MBA GAP C D 4.0 aligned faculty enablement program on industry practices in software development for complex interdisciplinary challenges, organized by the Department of Computer Science and Engineering at Adi Shankara Institute of Engineering and Technology. As educators, we continuously encourage our students to move beyond classroom learning and apply their knowledge to solve real world problems. One of the most effective ways to achieve this is through interdisciplinary projects that bring together expertise from multiple domains, fostering innovation, teamwork, and practical problem solving skills. Today's session is a wonderful example of such collaboration. We have with us a team of students who have successfully combined concepts from artificial intelligence, computer vision, robotics, and automation to develop the Adi Shankara facial robot. This project reflects not only their technical competence but also their creativity, dedication, and ability to work across disciplinary boundaries. The project showcases the integration of software intelligence with robotic systems, demonstrating how emerging technologies can be harnessed to create interactive and intelligent solutions. It stands as a testament to the innovative culture being nurtured within our institution. The computer science and engineering team comprises of Amrita, Abhiram, Abhinav, and Ashutosh under the guidance of Dr. Ramani Bai ma'am, and the robotics and automation team comprises of Shruti, Indrajit, Surya, and Sonu under the guidance of Dr. Sri Priya ma'am. We are delighted to have the student teams join us today for this session. Their journey from concept to implementation is sure to provide valuable insights into the process of interdisciplinary innovation and project development. I now invite the team to take over to begin their presentation and demonstration. Over to you, team.
Yeah, so hello, I am Abhiram R of the robot at the computer science department. So currently only 2 members are available to present, and we were offered only a short window to prepare the PPT. So it'll just be a brief description of our project and what we did in our collaboration. So the main problem that we identified in our project is that traditional methods of chatbots and typing online would not be interactive enough. So we thought direct communication with a human or robot would make it resemble more of like a human interaction. And the other problem that we wanted to solve is that traditional ancient philosophical figures like Adi Shankara, their knowledge and their personality has been lost, and we're not able to communicate with them. So with the help of artificial intelligence and the latest technologies, we're able to recreate their knowledge by storing it in a database and trying to mimic their way of speech using machine learning and other methods. So that's the 2 problems we aim to solve: direct communication with a robot and also preserving the knowledge of ancient philosophical figures. So as a result, we developed an interactive animatronic humanoid robot that bridges the gap between ancient wisdom and cutting edge technology. So this cannot be solved by one department alone. We need the assistance of robotics department to develop the hardware, whereas the computer science department developed the software part of the project. So this is the flow diagram, as you can see, of the project. There is edge computing and generative architecture. The edge computing is that there's the camera module and the neck mechanism. So the camera follows the user as the user is talking to the robot, and the neck turns and positions accordingly to where the user is positioned. And then there is the generative architecture, which is the voice pipeline. So once the user talks to the robot receives the voice, processes the question, pulls the information from online or from its local database, and then converts it to, and then generates an answer. The answer then has to be converted to facial movements, similar to how humans move their lips, eyes, eyebrows, etc. Similarly, the robot has to mimic those expressions so that it can talk to the user in a human-like expression. So this is the system architecture and design. First, there is perception and input processing. The architecture begins by capturing the user's speech. So the user's speech is recorded, and the user's expression is also recorded through a microphone, camera, etc. And then the next process is understanding the intent. That is understanding the question and finding the answer that is required to be output. So that's the intent and content understanding. That is done using RAG and predefined Vedic data sets to identify what the answer to the question is. Then we have voice and lip synchronization. The voice model, so there are mainly two models in this. There's the voice model and then the facial coordination model, facial coordinates model. The voice model takes the audio of the user and then generates an answer based on what the question is. Then the answer is passed on to the facial model, which converts the answer to facial robotic expressions, which accurately mimic how a human would say the same sentence. And then there is motor control and actuation. The coordinates that are generated of the face has to be passed on to the robot so that the robot can receive the angles and move the servos appropriately to mimic the speech. And then there is emotion and response adaptation. So the emotion is also recorded in the user's expression and the tone of voice. And once the answer is generated by the voice model, it is adjusted to the appropriate emotion, such as anger, patience, etc. There's also a self-learning module, which can be used to adapt. So if a user asks a question, that question is automatically stored in the database. It does not need to search the web to answer that question again. So department-wise contribution, this was a 50-50 collaboration between the robotics department and CS department. So the robotics department did the following activities, following parts of the project. They were involved with the mechanical design of the project. They 3D printed the components for the robot. They used embedded systems, programmed the microcontrollers and multiple PWM signals with power drops or jitter, without power drop or jitter. And then they also helped establish the control systems. So this is the work that the robotics department did. They modeled the components for the robot and then 3D printed and assembled them. So the CS department, we handled the part of vision tracking, which is tracking the user with the camera. We created the data set and the machine learning model for the robot to mimic human speech and also response, like the answer question model using RAG. And then there's also API integration with Sarvam AI, Google TTS to convert text to speech and then speech back to text for the whole pipeline to function. And then the core pipeline, which is the master script that runs concurrently, which combines the models, the voice model, the camera model, the vision model. It combines all of it and makes it one code sequence that can be executed with one click. So these are a few photos of our collaboration. We worked in the ASID library. A separate facility was provided for us by the management, and we were able to collaborate. These are some photos of our collaboration. And the true success lies in the integration. So this would not have been possible with one department alone. Because we had the collaboration of two departments, we were able to cover the fields that we were not familiar with. The robotics department helped with the mechanical aspects, whereas we were able to help with the software aspects of it. So this is the process of the project. The CS vision script updates the user's coordinates, sending target angles via communication to the robot's microcontrollers. And when a user speaks to the robot captures the speech, processes it, and speaks an output back to the user in a seamless way. And the synchronization script also plays audio through speakers. There are speakers placed next to the robot. There's also a microphone to capture the input and produce the output. So the main challenges that we faced were mainly navigating the timelines for each other's presentations. So robotics department would have like a update on the project and the presentation in a different week than our CS department. So we had to present the project again, but it helped us understand the project even more since we had to present it 1 or 2 times between multiple departments. And then there's also balancing the academic timelines. So some departments would have different assignments. We would have different workloads, but we were able to manage and work through the different timelines. And we also had to work outside of college hours, going to different going to different team members' houses, assembling the components. But it was a very what do you call eye-opening experience, and we learned a lot from the collaboration. So the outcomes is that mainly the project impact that we had, we successfully engineered a complex, culturally significant humanoid robot capable of real-time communication with users, and it serves as a proof of concept that of an interactive robot that can be used for education, exhibits, etc., and also be used to reconstruct ancient philosophical figures. The main key learnings that we achieved were cross-domain communication. We learned to collaborate between different departments, and the hurdle and the also navigated the problems and difficulties that come along with it. And we also achieved some technical milestones, mastering kinematics and integrating software into hardware components. And overall, it was a very exciting and educational experience for us. So, thank you.
So since we have a little arrangement issues, I'll show you the demo of working. Just a minute. So now this is the part where actually interacting through voice actually. So there I'll be playing second video showing all the possible movements and everything. Okay. Is the sound audible? The video has sound playing.
No, audio is not playing.
Okay. It's
Good morning, my friend. As the sun rises and illuminates the world, so does the light of wisdom within us. Welcome to this moment of shared understanding. What brings you here?
Tell me about yourself.
I am Adi Shankara, also known as Shankaracharya.
this video shows the maximum movement of the face and everything for facial tracking. As you saw, the movements and everything is very real like human. So we had to mainly add some damping functions, some PID controls to smoothen it. So sometimes jitters, but by fine tuning, we are able to achieve this smooth movement and everything. So this is currently outcome we are showing right now. If you have any doubts regarding the hardware or software, you could ask now, or we can contact later.
Dear participants, the platform is now open for questions or any discussions that you would want to make with the student team members. If you have any doubts, you're welcome to pose your questions to these students.
I would like to ask a question to the student team. So, how did you manage such an interdisciplinary project? How was it fitting to your curriculum, and how can other projects can be made such interdisciplinary in a university perspective, and how it is to manage your work in a interdisciplinary environment? Did you find anything challenging? How was your experience on this?
Well, the collaboration works in accordance with the syllabus. So we, as computer science students, also learn about artificial intelligence, machine learning, and we also got an opportunity to learn about robotics topics in syllabus. Also, robotics department taught us about different components and how they're integrated, and we also taught robotics departments different elements of software. So we both learned topics about each other's curriculum. And as for the management, we were able to manage the workload with the support of our teachers and our staff also. They allowed us some leeway in uh, working working in the library, working in different facilities. And also we worked outside of college hours also during the weekends, going to each other's homes and into collaborating there. So and overall it was a educational experience for both the departments and every team member, I think.
In the primary stage, the main thing is the robotics team can work separately, and the computer science team can work on their software individually. We might not need too much communication or too much time together. But in the final stages, where the integration part comes in, we both team has to work with this together. There was so much time we had to spend together in order for this to work properly. So even if there is some hardware changes, the software program has to be changed. If there is some software changes that can affect the hardware side also. So it's like a repetitive process. Actually, we did about 3 prototypes of this robotic head itself for making this fine-tuned process. So in the initial stages, we already did the face tracking and mimicking. Then in each of the steps, we gradually increased our output. That's how we achieved this much accuracy in face tracking and speaking.
We also developed the components in separate stages. So we had the voice module, we had the face module. So the robotics department completed their sections of the project, and we CS students also completed sections of the project independently. And then in the final stages, we had to integrate all the sections into one whole working project. That's where the majority of the collaboration time was spent. And there's also options for multiple different projects between many departments as well. Not just this. This is just one example of AI combining with robotics department. There can be many other examples and projects developed as well.
Working in such a big project, basically all team members can't work in a single topic. Everyone has to work on individual topics on their own in order for the less timing we have to do. So every member had different tasks to achieve within a time period. So if one of them lacks, the project would lag very much. So everyone was like most of the time working very hardly for achieving their goals. So the final stage integration, so we all had to work in together with this.
Hello, hello. Can you hear?
Yes, ma'am, please, you can ask your question.
Yeah. What was the total cost for the hardware component?
Sorry, can you repeat? I didn't hear.
Yeah, how much you have spent for the hardware components?
For the hardware components only, I think approximately above 1 lakh. It's an approximate amount. During the iteration process, some changes might be happening. So, approximately about 1 lakh spends has been done for the hardware only.
Okay.
I also have actually I have two questions. First is like which which part of your project was posing as the greatest technical challenge for you? Was it the AI model? Or was it the hardware integration part? Or the communication between your software and robotic components? Which part was the greatest technical challenge for you, and why did you consider it as a challenge? And that's the first question. And the second question, I basically want to know how scalable is your current design? Like if you were to, deploy like more than multiple robots in maybe, different environments within the college. Okay. So in that aspect, would you have to make a lot of, changes in your architecture? Uh, any changes in the design, just to understand the scalability of your current design. So these are the two questions.
So the most difficult aspect was mainly the testing of our code. So every time we tested, there would be minute errors everywhere. So, for example, when the facial servo movements were tested, sometimes the eye would not move, sometimes the jaw would not move. We had to check each individual servo to see if the connection was proper, if the proper power was being provided. And the other difficult part was the integration step. So we each developed individual components on our own, but integration is more difficult than that because we have to adapt each of our individual codes to understand each other's code and adapt into a single executable code line. So when we click enter, the robot has to just start working. So it was mainly the testing part that was causing us the most pain. And some components also broke during our testing because sometimes the angles of the jaw were not properly set. So the angles exceeded the limits and then the components broke. So sometimes we had to replace the components. We had to make sure there were limits on the movements of the angles and that each individual component was not damaged or each wire was connected properly. It's mainly the minute details that were giving us trouble. And I think this project is scalable. Our model can be deployed on any robot. If we make 50 copies of this robot, the same model can be applied on the 50 copies. It's a local model, so it does not require that many uh, cloud platforms for support. It can run locally. Most of the model can run locally. There are some elements that run on the cloud. So I think it's scalable if we make multiple copies of the robot as well.
Got it,
The
Abhiram.
hardware.
Thank you. Yeah. Yes. Yes.
Okay, so in the hardware design also, we have done it in 3D prints, but all of the designs are CNC compatible. So in order to making a much more industrial style, we can just easily CNC the parts also, all the body structures and everything. And also we have worked on the skins, on the facial skin with silicons. And even if we have to mimic someone else face, we can also do that easily. We just have to change the endpoints of the servos and the movement points, that's all. It's easily swappable with multiple human face. So it's like we can do it in diverse also.
Thank you, Yadu. Thank you, Abhiram, for answering the question and for giving a detailed explanation. Do we have any more questions from the audience, please? All right. So before we conclude, I would just like to. So thank you very much, Yadu. Thank you very much, Abhiram. To the audience, I would just like to inform. I just mentioned that today's demonstration of the Adi Shankara facial robot, it was just a bonus session which was added to our faculty enablement program. The original session that was scheduled had to be postponed because of some schedule issues of the resource person, which we guarantee that the session will be taken up uh, in one of the coming days. So thank you to the student teams for the impressive demonstration of the Adi Shankara facial robot. The project beautifully showcased the power of interdisciplinary collaboration and highlighted how the integration of software intelligence with robotic systems can lead to innovative and practical solutions. I sincerely appreciate the efforts of the students and the guidance provided by Dr. Ramini ma'am and Dr. Sripriya in bringing this project to fruition. The demonstration offered us a glimpse into how engineering education can effectively bridge theory and practice, empowering students to transform ideas into working solutions through innovation, perseverance, and teamwork. Thank you once again for sharing your work with us and inspiring us with your creativity, technical expertise, and collaborative spirit. I truly wish you all, on behalf of the whole department and all the guests and audience, I truly wish you all the very best in all your future endeavors, dear students. Thank you so much. Dear participants, this brings us to the end of today's session. As informed earlier, the session that was supposed to be handled during this slot will be conducted on a later date and time, which will be duly informed to you. So thank you all for joining today's session. Have a great day ahead. Thank you.